Assalamualaikum and hi. My name is Muhammad Amir Faris bin Muhammad Rizwan. So I will be presenting about our mini project for our subject of control system. So for the next slide, so meet our group. So our first member is Hazlina, and the second one is Najiha, and the third one is myself, Muhammad Amir Faris. So I will be the one that present our project today. So for the first question, we need to find or create a transfer function with at least one key value, two poles and three zeros. So as we can see here, the left box here shows the transfer function that we need to use for our project. So for the value of A, B, C, D, and E, we need to decide by ourselves. So for the value of zeros is 30 and 50. So for poles, -10, -20, and -40. So for the gain is 10. So the right box here shows the coding for Scilab that we need to use to generate this transfer function. So for the next slide, for question number 2, based on the above transfer function, we need to use Scilab and Bot plot technique to illustrate its amplitude response and phase response. And we need to show the gain crossover frequency, phase crossover frequency, gain margin, and phase margin for the transfer function. So after using Scilab, we will get the result like this. So this is the amplitude for magnitude and also phase. So for the value of the required for the question is, first is gain crossover frequency is 2.14 radian per second. So actually for our coding, we already make the value of frequency need to convert to radian per second. So the final value is 2.14 radian per second. So we doesn't need to convert the value. So for phase crossover frequency, we get 2.92 radian per second, and then for gain margin is 2.48 decibels, and for phase margin we get 35.105 degree. So this is the value from the bot plot. So we can see here the gain margin is 2.48, and for the phase crossover frequency is 2.91, and for phase margin here is 35.105, and then for gain crossover frequency is 2.14. So for question number 3, we need to use both lead capacitor to further improve 10% of current phase margin of the response, and we need to show the final transfer function of the capacitor and its phase and amplitude response. So first we need to do a little calculation before we proceed for our Scilab coding. So we need to find the new phase margin. Why we need to find the new phase margin? Because from the question, he wanted 10% further value or from the original value. So what we need to do is we can just multiply the original phase margin with 110%, because there is a 10% addition for the new phase margin. So we will get 38.61 degree. Next, we need to find phi max. The formula of phi max is the new phase margin we need to subtract with original phase margin, and then we need to plus with safety margin, and then we will get 18.51 degree. After that, what we need to do is we need to find the value of alpha. So the value of alpha here, as we can see, the value is 1.9304. After that, we need to find the value of tau. So to find the value of tau, we just need to substitute the value of alpha, and then we will get the new transfer function for our equation. Next, we just need to key in all the new value to the coding of Scilab, and we can just generate it, and we will get the new phase margin is negative 38.1094, and with the gain crossover frequency is 4.0876. So this is the amplitude response of magnitude and phase. Next, I will show you the phase margin response for the transfer function. And we also need to do the ramp response of the transfer function. So this is the ramp response of the transfer function. Okay, next. Question number 4. Use both LED capacitor to further improve 10% of current phase margin of the response. We need to show the final transfer function of the capacitor and its phase and amplitude response. So it different from the LED capacitor. So how we need to find the new phase margin for LED capacitor? So first step is we need to multiply the original phase margin with 10%. Then after we get the new phase margin, we need to add it with original phase margin and safety margin, the value of 5. So we will get 43.62, and then we need to find the frequency of phase. Where is it? We need to plus the value of negative 180 with the new phase margin, and then we will get the frequency is at negative 136.4 degree. So the new gain crossover frequency is 12.38 radian per second, and the gain at omega c is 0.5573 decibels, equals with 20 log alpha, and then we will get the value of alpha is 1.066. So next, we need to put 0.1 decay below omega c, thus we will get the value of z is 1.238, and write the phase later. And then from all of the value, we need to rewrite the phase lag network transfer function. So we will get the new transfer function for our question. So after that, we just need to put all of the new value in the Scilab, and then after we generate it, we will get the new value of phase margin is 43.09, and then for gain crossover frequency is 1.974. So from the coding, so it will also generate the amplitude response. So this is the amplitude response for magnitude and also phase. And then this is the phase margin amplitude response. Okay, next for the next picture is the ramp response of the transfer function. Next question. From the question of 3 and 4, we need to determine which capacitor that can be used to achieve 10% improvement of phase margin We also need to provide explanation. So this is our answer. Okay. The fixed margin for question 3 lead capacitor is 38.61 degree, and then for lead capacitor is 43.62 degree. So by comparing these two capacitor, the lead capacitor achieved a 10% improvement of phase margin as it is closer to uncapacitor value phase margin, which is 35.105 degree. And this also shows that the new value of gain crossover frequency is larger than the old value of gain crossover frequency. So based on the finding, the lead capacitor will be selected. Why lead capacitor been selected? Because lead capacitor consists of a dominant zero and a pole for the transfer function that will enhance the damping of all the system and lead to less overshoot, less rise time, and settling time. As a result, we will get a better transient response. And to improve the phase margin of system, a lead network will be applied because it can increase the bandwidth as well as giving a faster response to the system. The increase of phase margin will increase the stability of the system. As for lag capacitor, its attenuation will gain a lower point crossover frequency that will decrease the bandwidth and result to a slower response of the system. The lag capacitor will add a negative phase to the system, while the lead capacitor add a positive phase to the system. In conclusion, this shows that lead capacitor is recommended for the 10% improvement of the margin. So that's all from me and my group. Thank you.